Hello, class. This is Pre-Algebra, Chapter 4, Lesson 2, or 4.2, Equivalent Equations. Today we are going to talk about the word equivalent. Equivalent, or equivalence, is the idea that things are equal. So, for example, let's say we first spell the word. Okay, equi is our word part, is our base that we need, and that means equal or the same, right? You know words like equal. And what does it mean to be equal? Well, it just means balanced or the same, right? So in math, things that are equivalent are 2 plus 2 and 4. Those are worth the same amount, right? You got 2 over here and 2 here, and then you've got that same amount over here. And how do we show that they are equal or equivalent? We use the equal sign, right? Other things that are equal. Let's say 5 minus 3. It is equivalent to or equal to the same thing as saying 2. Well, how do we know that? Well, here's 2 things here. Here were 5 things, and we got rid of 3 of them. 1, 2, 3. We were left with 2. 2 and 2. Those are equivalent statements. 5 minus 3 is the same thing as saying 2, or they are equivalent. Equivalent. So today, what we are going to be talking about in variable expressions is equivalent equations. So here's where that looks like. Let's say you have the equation x minus 1 equals 9. Well, most people, or I'll say it's very easy to see that x minus 1, something, and you take away 1 equals 9, right? I mean, there's a couple ways you could do this. You could say, all right, look, 1, 2, 3, 4, 5, 6, 7, 8, 9. If you took 1 away from something, it would become 9. So here's the 9. I have to add 1 more to take it away, right? So altogether, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ah, behold, x here is 10. And if you take away 1, you will get this 9. 9 and x minus 1, when x is 10, are equivalent. And so over here, I could say x is 10 is one equation. And the other equation is x minus 1 equals 9. And those are equivalent equations. Are there any other equations that could be equivalent to x minus 1 equals 9 besides when x is 10? Well, sure. Let's say there was another equation over here that was x plus 1 equals 11. Basically, what we're asking is, in both of these equations, are the variables the same? Are the variables equal? If the variables are the same and they would work for both x minus 1 equals 9 and x plus 1 equals 11, well, then we have equivalent equations. So let's see if that's true. We already know that in this section, x is 10, or in this equation, x is 10. We know that 10 minus 1 is equal to 9, because 10 minus 1 is in fact 9. 9 is equal to 9, right? Well, let's see if we plug in 10 for x over here, would that work as well? Well, 10 plus 1 equals 11. Let's see if that's true. 10 plus 1 is 11. Well, how do you do? 11 is 11, so it works. So in this case, we know that x is equal to 10. And in this case over here, x is also equal to 10 to make both sides true. Therefore, we say that because the variables are the same in both equations, they are equivalent. Another way I could say that is, if I plug in the same value for x in both equations, will it make both equations true? If the answer is yes, they will come out true, then they are equivalent. If I plug in x for both and they don't come out true, then they are not equivalent. Let me show you what that means. Let's say here x was, oh, I don't know. Let's try a new one. Let's just try a new one. Let's see what we got, okay? Let's say I had x is 3, and over here, the other equation is 2x minus 6 equals 4. And the question asks, are these two equations equivalent? Basically, all they're asking is, if I plug in this value for x into this equation, will it come out with this answer? So let's try it. Maybe it will. 2x minus 6 equals 4. Is that true when x is replaced with 3? Well, I know that I can replace the variable with what it says the value is. So it's 2 times 3 minus 6 equals 4. Let's see if it's true. 2 times 3, according to PEMDAS, this is multiplication, right, is 6. 6 minus 6, does that equal 4? Well, 6 minus 6 is 0. 0 does not equal 4, ladies and gentlemen. Therefore, x equals 3, which is one equation, and 2x minus 6 equals 4, which is another equation, are not equivalent. And they are not equivalent because if I plug in this x equals 3 into 2x minus 6 equals 4, I will not get a true statement over here. Okay? Now let's say if I switch x equals 3 to, I don't know, let's say the number 5, right? If I change it to 5, what happens? Well, let's substitute the x for its value, which is now 5. And let's see what happens now. Well, 2x minus 6 equals 4. When x is 5, 2 times 5 is 10. 10 minus 6, what does that equal? Does it equal 4? 10 minus 6 is 4. 4 does equal 4, ladies and gentlemen. Therefore, when x is 5, 2x minus 6 does equal 4. Therefore, both of these equations, here's equation 1, here's equation 2, are equivalent. Oh, sorry, eraser. Are equivalent because it comes out with true statements.